With this, let me transfer it over to Abhishek to formally kickstart and then introduce his team as well. So over to you, Abhishek.
Thank you, Vikas, and thank you to all the InfoSec and IT leaders to give us an opportunity to present our solution, our new suite of solutions to use Zero Trust Networking. I also have with me my colleague Fuzail and Pawan. Fuzail will talk about, he's a field product specialist, he'll speak about Zero Trust Branch, and Pawan will be speaking about Zero Trust Cloud. Well, we are talking about Zero Trust a lot. So let's start by covering under the hood and seeing what really Zero Trust is. When we started this company more than 15 years back, we had few fundamental beliefs about Zero Trust. What were those? The first one is when it comes to Zero Trust connectivity, we connect the users and devices connect to an application or a destination and not to network. Second, network is not an arbiter of application access. What I mean by that is you use business policies and business logic, like sales users should get access to CRM application rather than using ACLs to provide access. So you use business logic to provide application access. And thirdly, in today's world where applications are everywhere beyond data center and users are everywhere beyond office, you have to minimize the attack surface. And these were the few tenets around which we built our product. We as an organization pioneered user access to internet and user access to private applications. And boy, many of you have been using it. We have been extremely successful. We take immense pride in being a pioneer in this product and to bring simplicity and better security outcomes for our users. Now, the world has fundamentally changed. More and more applications are on the cloud. They are everywhere. Similarly, there is a proliferation of IoT devices in offices, printers, scanners, card readers. And there is a proliferation of OT devices in factories, which brings with them their own set of challenges. And that's why there was this demand from our customers, from the market, to extend the same principles of Zero Trust, to extend the same architecture, the same concept beyond users to Zero Trust, to cloud, to factories, campuses, and offices. And that's how this Zero Trust networking as a stream was born. With Zero Trust networking, we are going to cover how do we secure the cloud. And next, how do we secure the branches, factories? So let's look at cloud, which Pawan would go greater into details. There are three areas which Pawan would be covering. First one, how to secure the access from cloud like AWS, Azure, GCP, or from your data center to the internet. Second, how do you segment applications which are between data centers, between CSPs? And thirdly, how do we segment workloads which are in the same VPC, same data centers? So these are the three areas which Pawan is going to cover. Next, we also have a concept of Zero Trust branch, which my colleague Fuzail will cover. So what's Zero Trust branch? You may have come across a term called branches like Starbucks or branches like cafes. What does that mean? Here also, we extend the same concept of Zero Trust to branches. Here, the branches don't have any attack surface. They're hidden from the internet. You log into a branch using internet. Internet is your medium of access, not expensive MPLS. But still, we reduce or eliminate your attack surface in branches. How do we do that? That's what we're going to discuss. The second aspect will be branches don't have with branches, each branch is an island. So you don't have lateral movement happening between branches because branch is an island. And thirdly, we have visibility and control over the communication within a branch. So if your devices are in a flat network, if you have limited visibility of your devices and how they are interacting with them within a branch, we can absolutely control it. And that's what my colleague Fuzail would cover. So with that, I hand it over to Pawan. Pawan, over to you.
Yep. Thanks, Abhishek. Let me share my screen. Okay. I hope you are able to see my screen, right?
Yes.
I mean, like I do have two screens as a reason. Okay, perfect. Okay, As Abhishek has mentioned, I will be covering more in detail about the cloud use cases to be precise, and then probably I will just hand it over to Fosel. He'll be going more in detail about the branch per se. But before jumping directly into the solution, I just want to spend like a couple of minutes here to explain like why we need a security solution for the cloud per se, so that you better understand like how Zscaler is different as compared to any traditional vendor to be precise. Now, this is a usual slide which I would usually start with any customer to be precise. Multi-cloud is a normal now, meaning like every customer will be having a multi-cloud environment. It's a developer world as well as it's a finance world to be precise. There's no networking play much over here. So if a developer comes and says like I need some service in a different cloud altogether because of my application is demanding it, then yes, you need to fire it up. So what the representation which we are giving here is like, so think about you have a small e-commerce application which is running on Azure as a front end, and you will be having a different services which are running on different clouds, like order status in GCP or inventory update in data center or shipping a status in the AWS to be precise. So even the front end is in one cloud, your backends are spread across all different clouds. As well as you do need to have a security for your workloads which are trying to access your third-party applications. So think about you do have some application services which are running on your own cloud, but there will be a requirement, especially which we have seen in the banking sector as well as the fintech sector, is they do have a requirement where they need to have a third-party API access which are running on the internet. So as of today, at least to start with, most of the customers, what they usually do is like they will just go ahead and build the firewalls, like how exactly you are seeing over here, and they'll be building the IPsec tunnels across these firewalls and make sure they are actually secure. But if you see here, this is not a proper solution to be precise, because obviously if you have a firewall and if it's exposed out on the internet, and if you do have a IPsec tunnels which are built using these firewalls, you will be having an attack surface which will be visible out on the internet. And also, thanks to IPsec, because they provide at the network level access. So even if there is a one cloud which gets impacted, it does mean like because of the network level access, even the other clouds will also get impacted. So that's where the latent movement comes into the play. And the last but not the least, the cyber threat and the data loss plays a major role when it comes to your workloads which are trying to access anything on the internet. It might be think about you have workloads which have access to your SharePoint or SAP services or anything to be precise. So the data loss prevention will also play a major role. Probably a bad actor who is just accessing your genuine workload and trying to upload some sensitive data onto your shared drive, or like onto his personal shared drive or OneDrive to be precise. So these are the common things which we have seen to be precise. And last but not the least, the complexity of the architecture itself. If you see on the left side, usually this is the mesh environment, what we have mostly seen with the most of the customers. They will be having the bunch of firewalls spread across like all clouds as well as data centers. And usually to have a multi-cloud connectivity, either they will be having the IPsec tunnels built across these firewalls, or they might be using the direct connects or express routes. Now, for example reference, whatever I have done is like I've just took one cloud here. Like for example, AWS is the cloud which I've taken over here. If you just zoom into this one particular cloud, and if you look into the architecture, how exactly you do as a if I'm running any third party vendor, which is a traditional vendor, this is nowhere related to the Zscaler to be precise. Like think about this is pre-Zscaler era. Like if I'm going and planning to secure any workloads, what you usually do is like in order to secure your internet traffic, meaning like your workloads trying to access something on the internet. For example, your production VPC or development VPC workloads trying to access something on the internet, then you will be having the internet facing firewalls. Okay, that's what we are seeing over here. And similarly, if you want to control the traffic between these VPCs, then you will be having another bunch of firewalls just to secure the east-west traffic. Usually we call it as east-west because it's in the same region, but you still want to have a control between this particular traffic. And last but not the least, you will be having another bunch of firewalls just to secure the multi-cloud connectivity, which is nothing but think about you have AWS East trying to talk with your Azure Central or some other region to be precise. Then you will be having another bunch of firewalls just having IPsec tunnels ending on different clouds to be precise. And on top of it, you will be having an management or orchestration VMs just to manage all these particular firewalls to be precise. This looks very good on the paper, to be honest. But think about a situation, you are exponentially increasing your VMs, as well as you want to do some kind of advanced filterings like SSL inspection or DLP or anything, which is touching your layers and packet, which is nothing but like you are opening up your layers and packet and trying to inspect like what's happening over there. Now, if the third party vendor, usually they say like we support 1 Gbps of throughput, but once you enable any kind of L7 filters, the throughput comes down like drastically for like 500 Mbps or 400 Mbps, which is nothing but like you might have planned for like I need like 1 Gbps of throughput, so you are just fired up like two VMs to be precise, and you are doing L7 inspection on your region where exactly you have it over here. But eventually, because the dynamic nature of the cloud, if the throughputs and if the number of VMs are keep on increasing, then you need to keep on adding more and more of your firewall VMs, whatever you are seeing here, which is again directly proportional to your management VMs also, to be precise. So what we are seeing over here is like, as the number of VMs increases, as your number of VPCs increases, as well as your traffic throughput gets increased, you need to keep on adding more and more firewalls because the whole processing itself is happening inside your own region using your traditional VMs. So just if you're turning on the SSL inspection itself, as I said, like the throughput gets decreased drastically by 50% to be precise. As I said. So this is the problem which we're going to solve. So now let's jump into like how exactly we are going to solve. So that's where it comes from the road from complexity to the simplicity. So what we are saying is like, if we as a zero trust and what we are calling and what we are saying is like, we want to have a firewall free protection, which is nothing but like the Zscaler, which is a POP which is sitting over here, which is nothing but like we have spread across all across the world, probably 160 plus regions. And what we are saying is like, we will take care of you doing the SSL inspection or DLP inspection. Everything will be taken care by Zscaler. And what we are asking you to do is like, you just forward the traffic to us, and we will make sure like it's completely secure. And same applies to the VPC to VPC communication or VM to VM communication. We'll go more in detail. But the main benefit as a customer for you is like, it's a single pane of glass and it's multi-cloud aware, which is nothing but like the same ZA portal or ZPA portal, whatever, if you know, like if you are using the Zscaler, you might be aware of these terms. It's the same portal which you'll be using for your multi-cloud connectivity, all the multi-cloud policies. And it's a completely zero trust based use cases, like using the tags and attributes, which we will cover as well. And it's a more simpler way of deploying things as we move forward. I think like you'll be understanding more. We do have something called as a zero trust cloud to be precise, which I will go more in detail as well. But the whole idea is like, you just forward the traffic to us and we will make sure it's always secure to be precise. How exactly? That's going to cover in the next slide. So that's where I'm going to introduce our product. We call it as a cloud connector. So the cloud connector is the one which you have to deploy in your own landing zone or in your own cloud to be precise, or security VPC or infra VPC, whatever you call, something like this over here, if you're able to see my screen. So what this cloud connector eventually will, it's doing, it's a small VM. It's a 2 vCPU 8 gig RAM VM. It's just a forwarding engine to be precise. What happens in the background is like, it will take the traffic from your VMs and it will forward the traffic to the closest zero trust exchange POP. So in short, this cloud connector, it's just building the tunnel to the closest POP, and it's making sure there is a connectivity always up and running to your closest POP to be precise. And you just forward the traffic to this cloud connector, and you define the policy saying like, I want to have internet security for your workloads. Or you say like, I want to have a multi-cloud connectivity for your workloads. Or I want to secure the VPC to VPC level security for my workloads. We cover all these kinds of use cases, which I will go more in detail as well. But net, these VMs, whatever you are seeing over here, they're just taking the traffic and intelligently forwarding traffic to the closest POP, depending your own policies. So think about, you say like, I just want the internet security for my production VPC. Then you just point the traffic to the cloud connector and it will just forward the traffic. And if you say like, there are some VMs, there are some research or pen test VMs, I want to completely bypass it, then yes, we even give you a complete flexibility for you to bypass the traffic from the cloud connector as well, to be precise. So as I said, the whole processing is happening in our zero trust exchange. So what does it mean? So when we say like we support 1 Gbps of throughput for this cloud connector VM, it does mean like, even though you are doing SSL inspection or DLP functions or any kind of L7 function, it doesn't matter to us because the whole processing is happening in our zero trust exchange, not inside your own cloud to be precise. That's the major benefit as a customer which you will be getting over here, where you will be completely ready for your scale out situations and you don't have to worry or you don't have to think about your VM bloating kind of situation, like where you every 3 months, every 6 months, I'm doing like I'm going to increase my number of workloads or VPCs. Do I need to worry about it? No, it's completely taken care by the cloud connector as well, and we do support autoscale and every option which we have on the industry. I will also cover we do have a managed solution to be precise, which goes in detail about like how we can from the Zscaler side how we can provide a managed solution even for this cloud connectors as well to be precise. So net, the main benefit as a customer, what you will be getting is like you will be not managing any of these cloud connector VMs. It's completely taken care by Zscaler. The patch updates, software updates, the only thing which you have to do is like you have to just deploy it. We do support all kinds of automations like the Terraform or CloudFormation, whatever you have as part of the industry standards. And the only thing which we ask you to do is like you just point the traffic to the cloud connector, and we will be building the tunnel to the closest POP, and we will forward the traffic to the Zero Trust Exchange. And you will get all kinds of layer 7 securities, whatever you want on our Zero Trust Exchange without any scale limitation, to be precise. So it's unlimited scale, to be honest. And we also provide you the multi-cloud connectivity as well as VPC to VPC level segmentation and VM to VM segmentation, which I will go more in detail to be precise. And I would like to take one thing at a time, like one step at a time. So I will cover like one use case at a time. So this is the first use case, which is majorly drawn by most of our customers. Majority of 1,000+ customers, whatever we have, like are using this as a intro stuff to be precise, like to secure their workload to internet traffic. So first and foremost use case is like think about you have a workloads which are trying to access the third-party APIs, especially that's a common use case across all industries. And what we are saying is like these connectors, whatever you are going to deploy, this delivers on all ports and protocols. So it can completely avoid the proxy as well as the firewall, because the proxy and firewall services will be taken care by Zscaler. And you will be getting the features, whatever I've mentioned on the left side and the right side, which is nothing but you will be getting an inline threat protection, which covers all kinds of cyber threat protections, as well as URL filtering, SSL inspection, everything. As well as you will also get the inline data protection, which is like advanced EDM, IDM matches, especially depending on like whatever use case which we have, we can completely cover as part of the DLP as well. So in short, the same connector provides you the firewall features as well as the DLP features, URL filtering, proxy features, SSL inspection, everything to be precise. And these are very small VMs, as I said, 2 vCPU, 8 GB RAM VMs, and these are like multi-cloud aware and single pane of glass to be precise. And we do support user-defined tags, which is nothing but like, because the cloud itself, it's very dynamic in nature. So most of the customers, they don't want to use IP address as a mechanism as part of the policy. So that's where we brought in this user-defined tag supports, where we natively integrate with your cloud vendors like AWS, Azure, and GCP, and where we can read your tags and you can use these tags as part of the policy. So think about you have a you have a service called as like application equals to finance, or a set of VMs, probably 10 VMs, which are using a tag called as application equals to finance, and you want to allow Salesforce.com for it. Now you can define a policy saying app equals to finance as my tag should have access to Salesforce.com. Even though if there is a scale out event happens, so probably you are running 10 VMs now because there is some event which is happening, there is a scale out event happen. So the 10 VMs might have increased to 50 VMs. You don't have to worry about the number of VMs or number of IPs, because under the hood, we will be mapping that IPs to the tags, and we will be automatically updating your database. So you are completely covered in your scale out or scale in situations. You won't be giving any liberal access, rather you will be giving more restricted access to your VMs, because you are giving the access based on the tags, as well as we do support attributes. So if you say like, I don't want to use tags, is there any other option? Yes, we do support attributes. Attributes are something like the VPC ID, subnet ID, or the instance ID, or the ASD group ID. So these are the things which you actually use as part of your policy as well. So we do support tags as well as the attributes. And the beauty of this product is like, it's a multi-cloud aware. So if you have standardizing your tagging mechanism across all 3 clouds, then you can use a single rule which applies for all three clouds as well. So we do have other mechanisms where you can go ahead and configure at a multi-cloud level for this tagging purpose, or you can do it at the individual cloud level as well, to be precise. And this taggings or will be available for your firewall filtering or URL filtering or SSL inspection or DLP as well, to be precise, like whatever we have mentioned earlier, to be precise. And just to be reiterate, there are like three use cases which I would like to stress. One is like the north-south firewalls, which is not like which I have covered earlier, like the secure workload to internet, which is nothing but your workloads trying to access the internet. And the second one is like the multi-cloud connectivity or hybrid cloud connectivity, which is nothing but like cloud-to-cloud connectivity, which we are going to stress more in detail in next slides. And the last but not the least, we will also spending a little bit more time on the east-west firewalls, which is nothing but controlling the traffic between the subnets or the VPCs, as well as controlling the traffic at the VM level or the process level, to be precise. That said, I just want to reiterate, these are some new innovations which we are bringing in. So zero trust for the hybrid cloud, which is nothing but like we do support AWS, Azure, GCP, as well as we do support on-prem data centers as well. So that's what we are stressing over here. And we do support all kinds of use cases, which I've mentioned earlier, which is nothing but the east-west support, as well as identity-based policy as well. We can go granular at the IP level or at the tag level, to be precise. And the last but not the least, operational simplicity is the one which we have majorly worked on it. It's a zero-click deployment, which I will go more in detail. It's a gateway service which we have brought in, where you don't have to deploy or you don't have to manage anything. You will get completely services deployed, managed by the Zscaler, and you have to just point your traffic to us. I will explain more in detail, and which will help you to secure your traffic without any operation dependencies, to be precise. That said, let me just go into the Zero Trust Gateway service. Earlier, if you see, as I said, like you have to deploy the cloud connectors and manage yourself. But as a customer, if you say like, no, I don't want to deploy anything, is there any option from the Zscaler which you are going to provide? That's where we have a option called as a Zero Trust Gateway service, which is nothing but like we as a Zscaler will be completely hosting this cloud connectors, managing this cloud connectors. And the only thing as a customer which you have to do is you just route the traffic to this cloud connectors. How exactly? It's nothing but like we are using the gateway load balancer service, to be precise, and we are going to give you a service endpoint which you will be using or as part of your routing mechanism, which I will go more in detail as well. But the whole purpose of this one is like, in short, as a customer, you don't have to manage anything. And the major benefit is the cost per se, because the hosting cost will be completely get rid of it, because you are not going to deploy even the cloud connectors. Rather, you just point the traffic to us and we will make sure it's completely secure. And you don't have to deploy any NAT gateway services, or you don't have to pay any egress bandwidth services. So in short, the NAT gateways or the egress bandwidth will be completely taken care by Zscaler itself. And this supports up to 40 Gbps of throughput. So it's completely aware, and we can do the auto scale out, and we support all kinds of regions, whatever we have as of today as well. And the main benefit or the main benefit or like the main use case which we are trying to solve here is like, as a customer, you don't have to manage anything. This is mainly beneficial for the cloud native customers. So if you say like, Pawan, I don't want to manage anything, is there any option from the Zscaler? Then this is the proposal which we have, where you don't have to deploy anything. You don't have to worry about the security groups, or you don't have to worry about the VM sizing and everything. Rather, you have to just go ahead and create an endpoint and just route the traffic through it. How exactly, we'll go a little bit more in detail. So it's a simple three-step process, to be precise. And to be honest, the POC can be done in 10 minutes. I'm not exaggerating it. This is what the customers are doing it. So if you're interested, just feel free to reach out to us. So first and foremost thing is like, you will create something called as a Zero Trust Gateway instance as part of your Zscaler console. So we do have a Cloud Creator console. Over there, you have to create something called as a Zero Trust Gateway instance, which is nothing but like, so think about you want this service in Mumbai region. So you go to the Mumbai region and you say like, okay, I want a Zero Trust Gateway instance. That's what you are intimating to the Zscaler. And once it's been done, you have to just go to your AWS console and you have to create an AWS endpoint, and you have to just update the route table. And if you see this process, you're not deploying any VMs over here. Rather, you are just intimating to the Zscaler saying like, you just deploy the services on behalf of me and give me the endpoint service so that I will create an endpoint. When I say I, the customer, you will be creating an endpoint and you will be just updating your route table and forward the traffic to the zero trust exchange to be precise. So these are all the screenshots which we have. So which is nothing but you just enter the configuration where exactly you are interested in. For example, you say like Mumbai is the region I'm interested in, and you say like these are the availability zones which I'm interested in, and just click next. And you allow the locations or you allow the accounts, whatever, or from where exactly you will send the traffic. So these are the allowed accounts, which is nothing but these are the accounts which is been owned by you. So as a customer, you will be having a bunch of accounts. What we are saying is like you use your accounts and just allow this only accounts for this gateway service so that the gateway service will only accept the traffic from a set of accounts, whatever you as a customer is owning it to be precise. And just review whatever you have created and just submit it to be precise. And on from the AWS side, this is the only thing which you have to do, where you have to just update your uh, or create your AWS endpoint as well as update your route table pointing all your egress traffic, a default route pointed to the endpoint, whatever we have provided to you as a customer to be precise. So in this whole process, I just want to reiterate, you are not going to deploy any VMs. You are not going to manage any VMs. You are not going to deploy any NAT gateways or anything. Rather, you are taking a service from Zscaler and pointing your route table to it to be precise. And this is only available in AWS as of today. We are working on Azure and GCP. So if you are ready or if you want to try it out on AWS something, as I said, it's hardly takes 10 minutes in order to the POC. So just feel free to reach out to Abhishek, so you can just arrange anything to be precise to, or if you want to go more in detail as well. Okay, and let's jump the gears into the east-west side, which is nothing but like the macro as well as the micro segmentation. This is a common use case where customers do want to secure the traffic across two subnets or two VPCs or across two VMs. This is a very, very common use case to be precise, where they want to avoid the lateral threat movement and they want to have a zero trust principles even when the traffic is uh, communication happens between the internal networks, like at the subnet level or inside the subnet level as well. So earlier we have seen workload to internet, as well as we have seen like the multi-cloud connectivity. Now we are going more granularly and we are saying like, if you want to control the traffic inside the VPC or the VPC to VPC level or the subnet to subnet level, and the next step will be VM to VM level also we should be able to support using our micro-segmentation agent to be precise. So the first slide, the first section which was saying here is the same connector, the cloud connector which we have mentioned over here earlier. That's the same connector can be used to control the traffic from VPC to VPC or VNet to VNet, as well as subnet to subnet level as well. This is a common use case. Most of the customers wants to control east-west traffic, or they want to have some level of segmentation at the subnet level or at the VPC level when the communication happens internally, rather than depending on the security groups. So the same cloud connector which I've mentioned earlier, the same connector can be used over here. Or if you say like, is this something or even can be managed by Zscaler using like whatever service which I mentioned earlier? Yes, we do support it using the ZT gateway service as well. So instead of you hosting these connectors, we can even leverage our gateway service, which will be completely managed by Zscaler, and you can still be control the VNet to VNet communication or subnet to subnet communication without any agents. I'm just stressing this point. This is an agentless solution. You're not going to deploy any agent on the VMs. Rather, you are going to use the same connector to control the traffic between two VNets or two subnets to be precise. And if you zoom in more in detail, where we also support VM to VM communication as well. So this is mostly beneficial for your crown jewel applications, where you say like, I do have so secured application where I want to have a host level firewall. I want to control the traffic at the host level itself. Then we do have a micro segmentation as an option, where we have a lightweight agent, micro segmentation agent to be precise, which you have to deploy as part of your Windows VM or Linux VM, and it can control the traffic at the VM level as well. So both options are available. It's up to the customers if you want to do at the subnet level or VNet level. Or if you say like, I want to do both, yes, both are also available, as you can see on this particular screen. And also, we do share the intelligence. So if you are using the both, so we do have plans to share the intelligence. So think about this agents will also talk with our connectors and share the intelligence and risk and the score mechanism, so that if there is any malware or any different behavior of a service or a VM, then we should be in a situation to control that particular VM or a service, to be precise. So that's the plan which we have. Whatever you are seeing here, it's already available. So just feel free to reach out to us. We can go more in detail as well. But to be precise, the whole idea is like the connector will be able to control your traffic at the VNet to VNet level. And if you want a host level controls as well, then we do have a micro-segmentation as an option, where you can deploy this agent at each VM level, which will able to control the traffic at the VM level. This you can compare with the Akamai Guardicore or Colourtokens, to be precise, where you can control the traffic at the VM level, to be precise. And when it comes to the micro-segmentation, as I said, one option is like you deploy the connector in order to control the traffic from the VPC to VPC level. Or if you do want to have a control at the VM to VM level, then you need to go ahead and use the agent, which gets deployed on the VM itself. When it comes to the micro-segmentation, as I said, like, as we've spoken earlier as well, it provides your continuous monitoring as well as continuous enforcement. It's a agent-based solution, as I mentioned earlier, which gives you a complete flow information about like whatever the traffic which is going from that particular VM at a port level, at a process level, so you can understand what's happening at a port level, at a VM level. And we do have intelligence built into this particular agent, where we can give you AML-based policy recommendations depending on your traffic flow, so that you can define the policies for these agents automatically. You don't have to worry about like, okay, I do have like 1,000 servers or 10,000 servers. How do I define policy? So we do look into your traffic analysis, and we'll see how much traffic or what kind of traffic which is going through it. And accordingly, we will also propose the policies to you for the micro-segmentation purpose, to be precise. So this is how it's going to look like when it comes to the Zscaler micro-segmentation, which is an agent-based solution. If you're aware of the ZPA console, which is already there, so that's where this product is available. First and foremost is like you have to just log in to ZPA console and download the micro-segmentation agent. And you have to install this agent across all your VMs. We do support all kinds of automations like the Terraform as well, or like we do have documentation like exactly like how it can be done using your CI/CD pipeline as well for your Windows or Linux systems, whatever systems which you have. And once the agents are been installed, these agents will automatically get registered to your tenant or the Zero Trust Exchange. And once it's been done, then you have to just review your inventory and define the policy, how exactly this agent has to control the traffic between the VMs itself. I'm just stressing this point. If you want the VM level control, that's when you need to use this Zscaler micro-segmentation as a solution, which gives you the host level segmentation where the control happens at the VM level itself. Or if you say, Pawan, I want to take like one step at a time, can we go ahead in a processed manner? Then I would usually say like to the customers, like use the connector for your VNet to VNet communication or subnet to subnet communication. And once you feel comfortable, then go ahead and deploy these agents in order to control the VM to VM as well, to be precise. Okay, that's pretty much on my side. I will now just hand it over to Fazal so he can go more in detail on the brand side. And yes, I've just given it a high level overview, but if you want more details or if you want detailed discussion, because of the time limits, I just have given a little bit of overview itself.
There'll be a QR code at the end of the slide. Please scan it if you want more details. Thank you. Thanks, Pawan. Over to you, Fazal.
Yeah. Thank you so much. Thanks a lot. So thank you so much, everyone, for joining the call. Thank you for your valuable time. So I'll walk you through about Zero Trust Branch, what exactly it is, as Abhishek here has highlighted, and he has shared brief information about what is Zero Trust Branch. Zero Trust Branch, it includes three communication: the secure outbound communication, secure inbound communication, and the secure communication within that branch itself. I'll briefly talk about how do we do that as of now? If we have a branch or if we have multiple locations, how do we make sure that, okay, it allows communications from that branch outside or inside? And how do we ensure that, okay, it should be secure communication as of now? So if you look at this slide, you would see most of the legacy architectures or legacy, I would say vendors, they have been using this traditionally, that you have more than one sites. There might be that, okay, you have the complete security fleet available at your data center or HQ. You backhaul all the traffic to the data center or the HQ, and then it goes and access the final application. Application could reside at your data center, or it might be in the public. But what happened that most of the users, they started working from home during COVID, and they experienced that, okay, they have better even experience working from home, because these days most of the users, they have been using SaaS based applications, and they had to access those all applications directly, so they got better experience. When they came back to the office, they experienced that, okay, now the behavior has been changed, the experience has been changed. Now they don't experience the similar what they used to experience when they work from home. So most of the organizations, they started thinking about this, that, okay, how do we ensure that, okay, the users experience, it should not get changed. They should be able to get exact same experience what they were doing when they were working from home. They started thinking about that, okay, how do we do local breakout? The moment you start thinking about the local breakout, you need to make sure that, okay, you have to have the entire security fleet available at that site as well. This was the first challenge. The second challenge, when you make sure that, okay, the all location or the branches, if they need to talk to each other, they have to build some sort of communication tunnel between those locations. So most of the vendor, you would see, they go with IPsec VPN. They make sure that, okay, each locations, whether it is their remote location, branch or campus, or maybe data center, they talk to each other through full mesh, and they establish IPsec VPN. On top of that, they would exchange routes to make sure that, okay, each location or each site is reachable over that tunnel. What happens, what it brings in, of course, it simplifies it. You get the access, you can reach out to the destination, but to establish IPsec VPN, it has to be in listening mode. The moment I say that, okay, it has to be in listening mode, that means the public IP address needs to be listening on port 500 or 4500. The moment we open a port, an IP, attacker can perform reconnaissance attack that, okay, yes, this IP is reachable. If IP is reachable, it can be breachable as well. So indirectly, it increases the attack surface. And in case of IPsec VPN, normally you just build the tunnel, like you build the road, and then you are good to go wherever you want to go. If you want to have a checkpost, of course, you need to spend some amount on that as well. You need to build the checkpost at every point where you want to block it or you want to take action, that who is allowed, who is not allowed. That is about security investment. So first, it allows lateral movement without security investment. So attack surface gets increased, lateral movement is possible. To stop that, security control investment needs to be done. The third thing is, that is very critical, that most of the organizations, they might have 100 or even might have 500 or 1,000 branches or locations. They have to rely on BGP, border gateway protocol, and that routing becomes very complicated. And convergence also, it takes a lot of time. Troubleshooting, it takes a lot of time. User has to maintain a lot of routes, and troubleshooting is nightmare. It's not so easy. And even in certain cases, you would see a lot of vendors, they say that, okay, you have to have headend as well, that you need to deploy somewhere in your data center or HQ. You need to manage that headend as well. It might be deployed in the cloud as well, but most of the customers, you would see that, okay, it has been deployed at their data center, and it becomes a single point of failure as well. If it gets failed, everything is gone. They lose the connectivity, they lose everything. How do we solve it? What exactly we do? So we have a concept of zero trust branch, a cafe-like experience, as Abhishek highlighted that. We have one solution known as Zscaler Edge that has two components. We call it zero trust SD-WAN, zero trust device segmentation. With these two components, what we do, we make sure that, okay, we provide secure external communication from that location, secure internal communication from that location. And how does it happen? And what exactly it does. So as I mentioned, if I do a local breakout at each location, I need to make sure that, okay, I have to have a device that should be able to build IPsec VPN should have a device that should be supporting BGP, should be able to manage the routes requirement. It should be capable enough to carry that many routes. We should have a security fleet as well to make sure that, okay, the traffic is getting inspected. So finally, we end up having more and more point products at that location. And that includes like VPNs, firewalls, it might be NAC as well. And if we could further go down and we try to find out that, okay, what all devices we have available at that location, a kind of asset discovery, we need to have some other solution as well. We eliminate everything in one go with one solution. That is our zero trust branch, that we have just one appliance there and everything is being taken care. From that appliance, we would allow secure outbound connection, secure inbound connection, secure inside communication as well by eliminating these all, whether it is north-south firewall, east-west firewall, VPNs or NAC that we have already deployed. How do we differ from traditional architecture? In traditional architecture, we just saw that, okay, each location has to build IPsec VPN with all the locations wherever it wants to communicate. We build only one tunnel from that location to our zero trust exchange. We don't build tunnel to any other location. Each location is just an island in itself, and it just builds the tunnel to zero trust exchange, and we initiate outbound tunnel communication. We don't listen on any port. It's outbound communication that will be initiated. We would build the tunnel from that location to the zero trust exchange, and we reach out to any other location, whether it is in HQ, whether it is campus, branch, or any remote location, whether it is cloud, we would reach out through Zero Trust Exchange. And Zero Trust Exchange has the entire security fleet that would inspect the traffic, and we intelligently control the traffic there by adding the policies that, okay, what needs to be allowed, what does not need to be allowed. This is the fundamental shift from traditional network, that we don't expose our location or branch. We limit it, we make it an island that is not at all reachable. If it is not reachable, no one can even perform a reconnaissance attack. This is the first difference. The moment we make that it builds only one tunnel or only one communication channel from that branch or that location to ZTE, there is no lateral movement between branch or between the location. We kill it right away there. Anything that needs to move out from that location, it has to go through with the Zero Trust Exchange. Anything that has to come inside that location, it has to go through with the Zero Trust Exchange. No two locations can talk to each other directly. This is the second difference, that the lateral movement is completely blocked. The third, we don't rely on routing. We don't add any sort of routes to reach out to any destination. There is a fundamental difference in that as well, that we don't reach out to the network, we reach to application only. If any user wants to access private application, or if any non-user endpoints attempt to access any application hosted in private data center, hosted in public data center, or maybe a SaaS-based application, we would find out that where is that application, and we connect to Zero Trust Exchange. There is a broker that would find out where we have that application, and it would establish a tunnel, and we stitch those tunnel to give only a specific application access in case of private application. So having that, we get rid of routing table management. We don't need to bother about that. Even in case of troubleshooting, we don't need to review 1,000 routes. We need to find out that, okay, do we have reachability or not? In this case, we minimize number of VPNs supported as well. We don't get into a situation where we need to find out that, okay, how many IPsec VPN, how many tunnels that is supported at our head end. The moment we start growing, we need to evaluate that as well. With legacy architecture, with Zscaler, we don't need to bother about that. So with one solution, we get rid of attack surface, we minimize it largely. We get rid of lateral movement. We get rid of complex routing. We get rid of hidden management. It makes it very simple. And I'll explain it in a couple of other slides. How do we ensure that when we access anything outside, how it is being secured? When we access internally, east-west, how do we secure that? And when someone attempts to access from outside to inside our network, such as in case of OT environments, a vendor, they want to take RDP. They want to do some sort of troubleshooting. How do they come inside and securely access that? And we keep track of that as well. I would double click on that as well. So the key use cases, when we talk about zero trust branch, there could be three main communication: secure external communication, internal communication, and visibility. Visibility is very, very important in security. The more and more we have visibility, we can apply better and better control on that. So in case of external communication, regardless in that branch, whether we have user, non-user endpoints such as IoT endpoints, OT endpoints, or in short, I can say headless, or maybe servers, regardless whether we have any sort of clients installed on that endpoint or not, we can provide secure outbound communication with Zscaler Edge. Secure internal communication, the same goes. We don't rely on any agents, any type of endpoint, whether it is headless, whether it is user, we can provide secure communication between two endpoints. And that is very, very important, even though those endpoints are part of the same broadcast domain. That means even if those endpoints sitting in the same VLAN, we can provide intelligent control between those endpoints, which are even though part of the same broadcast domain. The third, which you see here, is about the visibility. The moment we see the very first packet, we identify that, okay, what kind of asset this is, and we add that information into the asset inventory list, and we start building more and more information about that asset. We call it attributes, and we populate somewhere close to 30 to 35 attributes for each asset. And then we provide option for the user to intelligently control the traffic between endpoints based on discovered attributes, not based on the legacy way of controlling the communication, that is source IP, destination port, and protocol.
Hey, Faisal, sorry to intervene. We are running out of time. It's already 11:51. So maybe you can take one more minute and then we need to close. Okay,
we have a lot of
another 5
to
minutes. Let's have another 5 minutes at least. For
yeah.
Sure.
Let me quickly cover that.
Yeah, not beyond 5 minutes, please.
Sure. Let me try to cover in just 5 minutes. So I'll just quickly cover the three components. One, we call it branch connector. You just need internet connection, and you have secure inbound and outbound connectivity. What it does, as I have mentioned, you can have anything behind that branch connector, whether it is your user VLAN, IoT VLANs, or OT VLANs. They would send the traffic to branch connector, and we can act as an inter VLAN firewall as well. We can control their east-west communication, and at the same time, we would allow them to have internet access or private application access securely. I'll not cover in detail. This is about our ZTDS. We call it Zero Trust Device Segmentation. This ensures that devices or the endpoints that we have in our LAN, each endpoint gets ring-fenced, and we make it an island in itself. We assign /32 subnet mask. So any endpoint needs to communicate to any other endpoint, whether part of the same VLAN or different VLAN. It has to go to the ZTDS gateway. And at ZTDS gateway, as I mentioned, you have already added the policy with the help of discovered attributes, and you control the communication intelligently. We have a couple of other features that is really amazing. I don't have much time to cover that. Let me quickly cover about PRA. PRA, as I have mentioned, this is privileged remote access. If anyone wants to have remote access such as RDP, SSH, VNC to the internal, let's say maybe servers, maybe your OT endpoints, and you want to have secure access, you can have granular control on this, that you can give them just time-based access, that you have access for so-and-so time. If a file needs to be uploaded on that, it will be first sandboxed. It will be verified that, okay, if file is clean, then only it will be uploaded to that machine, and it can be utilized, such as someone needs to perform software upgrade. We can do complete session tracking. We can record that and we can review it so that if we give access to such as vendor, we can go back and always check that, okay, what command has been run, what troubleshooting has been done, what kind of information they have captured or they have taken, or what information they have supplied. You can review each and every information. This is very important, very secure way to give them access to only a specific endpoint, and you have the complete tracking as well. Having said so, I would conclude this. Thank you so much for your time. Thanks a lot.